Okay, this is our second video talking about how to graph rational functions. We're going to focus first on one of our first basic ideas, which is finding the domain of the rational function. So here's a rational function. And again, a reminder, we always start with the thought that the domain could be negative infinity to infinity. We have a polynomial in the numerator, so we're going to go ahead and factor that, and that's what you should think anytime you see it. So we factor it into x minus 3, x plus 3, and then we write down our denominator, x minus 3. Now when we're trying to determine domain, the denominator is the most important thing that we're looking at. So we take the denominator and set it equal to 0, and then solve, and we get x equals 3. So this is the one value which needs to be restricted from our domain. We're not allowed to use the value 3 because when we plug that into the denominator, we would get 0, and we're not allowed to divide by 0. So we're going to write our domain in interval notation, negative infinity to 3, union 3 to infinity. So that's the domain for this function, and we'll actually turn it into a function by letting it equal f of x. Let's look at another example. Oh, we need to look at one more thing here. Notice that we have a factor in the numerator and the denominator that are the same. So we're going to cross those off, and when we go to graph this, it's actually going to look like y equals x plus 3. However, this restriction on the domain still remains, so this is actually going to be a whole. So you have to be very careful when you read a question. If it's asking you for the domain of the function is this interval down here. If you're being asked about an asymptote, it does not have a vertical asymptote, but it does have a hole at the value where at the point where x would equal 3. All right, let's look at another example. Here we have a polynomial in the denominator. That's well said. We'll let this one be h of x. So we're going to factor our denominator. We get x plus 4 and x minus 4. That means we will set each of these equal to 0 in the denominator. X plus 4 equals 0. X minus 4 equals 0. And so x cannot equal negative 4 or 4. Now in this case, we're not going to be able to cancel that with any of these factors, top and bottom. So we're going to actually have asymptotes on this one. But right now we're just focusing on finding domain. So the domain is from negative infinity to negative 4, unioned with negative 4 to 4, unioned with 4 to infinity. So there are 3 sections to the domain, and negative 4 and 4 have to be excluded. All right, our last example for finding domain is we have a polynomial on the bottom. So we set that equal to 0, but then this is not factorable. And if you're not sure, if you let x squared equal negative 4, you would end up with plus or minus 2i. And I is not part of our normal graphing coordinate system. So this one has no restriction on the domain, so the domain is from negative infinity to positive infinity. And as we're going to talk about in the next section, the next video on asymptotes, this means that this function has no vertical asymptotes. All right, So this is the video discussing domain, and the next video, which would be the third video, we will talk about asymptotes. So I hope you will move on to that video next.